Hey Peter, so I thought I'd just send you a quick video to explain a little bit more of what they want from you in this section on Khan Academy. It really is a complex process they're having you go through, and it really depends what you've had before. So I'm going to assume a couple things, but please stop me and tell me if there are certain things you haven't gone over in math before. But I thought I'd just dive into an example problem because sometimes it's easiest to show things through an example than explaining it just theoretically. So this is one of the problems Khan gave me when I went in, like I was going to take the little quiz about finding the angle of complex numbers. So when they're asking you to find the angle, first of all, just a reminder that this form is a complex number written in the form where we have a real component and an imaginary component. So for the most part, this is what you're going to be using most often. The thing they're having you change it to in other forms where you might have seen them having e with an exponent, that's rare that you'll be using it in pre-calculus. So don't get caught up on the complexity of that part, but focus on this form because this is sort of the more standard form you'll be using more often. And the key is looking at this and being able to graph it on a graph. And I'm just going to do that right down here. So I don't know if you noticed in the video, they graph instead of an XY, they have a graph where one side, your x-axis is your real number, and your imaginary axis is your imaginary number, or your y-axis is the imaginary number. So you go ahead and graph this sort of as if the 4 is the x and the 3 is the y, sort of. So you take your 4 on my real axis, and I'm just going to go to 4, and my 3 on the y-axis. So that point would be approximately here. This is very sketchy and not perfect, but it's just sort of for display sake. So what they're really looking for when they're asking for this angle is to find the angle that comes up to this line that's created on this graph. So to find that angle, they want you to look and see, here is a triangle I can look at. And what I find very helpful is to rewrite your triangle away from your original graph, just so you can really focus on the pieces of it. So we've created a right triangle because we came straight down. And we can label the sides of our triangle based on what they were on the graph. So we know here we came over 4 units, so we can label this side with a 4. And we know we went up 3 imaginary units, so we're putting 3 over here. So what they're really looking for is this angle. And to find this angle, we need to use trigonometry. So this is where I'm curious too on how much trigonometry you've had. So the basic thing in trigonometry is sine, cosine, and tangent. And those just help us find these relationships where you are able to find this angle just given 2 of the sides of a triangle. And so I don't know how you remembered sine, cosine, and tangent if you learned that before, but the way I remember it is a mnemonic that says Oscar had a heap of apples. And the O's stand for opposite side, the H's stand for hypotenuse, and the A's stand for the adjacent side. So if I'm looking for this angle, I know the opposite side of that angle and I know the adjacent side. So because I know these two, I'm going to use the tangent to find that angle. So oftentimes too, when you're dealing with an angle, the variable you use for an angle is theta. That's what they're using here as well. So I'm just going to call this angle theta for now. So I'm going to say the tangent of theta has to be the opposite side, which is 3, over the adjacent side, which is 4. So to actually find theta now, we can solve for theta by putting theta by itself and moving the tangent to the other side, making it the inverse tangent of 3/4. So you would literally put this in your calculator, 3 divided by 4, And then once you have that number, you hit the inverse tangent key on your calculator. Even your phone calculator has this. If you turn it to the side, you usually have to hit the button that says second. And when you do that, it turns your keyboard and you'll then see this inverse tangent button. So once you divide 3 divided by 4, you get 0.75. And then if you hit the inverse tangent button, you get 36. And then in the instructions, it wants you to round your answer to the nearest thousandth. So I'm going to go ahead and go out to the thousandth place right now. So I'll do 8. Let's see. It's supposed to be 869, but I need to round up the 9. So it'll be this. Okay, so this is my angle right here. Now, unfortunately, in this particular problem, we're not quite done yet because we just solved this in degrees. And they're asking in this particular problem to express your number in radians between negative pi and pi. So we now need to convert this to radians, or probably what I could have done, I could just convert this to radians now, or instead, in this step, when I typed stuff into my calculator, instead of just typing it in the regular mode the calculator's in, there's a mode in your calculator that when you click this symbol, it puts you into radian mode. So I'm going to click that on mine right now and do my 3 divided by 4 again. And then I'm going to hit my second and my inverse tangent. So when I do it this way in radians now, I find the answer is 0.644 in radians. So that's the same thing in radians. And when they say between negative pi and pi, just as a reminder, going all the way around a graph would be 2 pi. So coming here, this is, if you start here at 0, and then this is half pi, this is pi coming over here, and then this is 3/2 pi. So going all the way around is 2 full pi. But they want your answer, they just want to make sure you're keeping it either in this quadrant between 0 and pi, or if your answer happens to be in one of these quadrants, you're going to come negative and do it from that perspective. But in this particular situation, since our thing is in the first quadrant, we don't have a problem because we're less than half pi anyway. So I'm going to go back to my Khan Academy and put this answer in and double check that it's correct because I just worked it out with you here. I hadn't checked it beforehand. So hopefully this one makes sense, and then I am going to add in another example problem from the next section. Okay, I just double checked that answer and we were correct. So let's put in our next problem. So in this problem, this is in that next section, this problem talks about finding, not just focusing on, like, you're given the angle and you're given the magnitude to begin with, and you need to put it back in this regular standard form. So this is also a question I have for you, and let me know if you have not gone over this before, but there's something you often learn where you convert what they call rectangular coordinates. And rectangular coordinates are written in like an XY form. So, you would have the point right here would be the point 2, 3. Written in rectangular coordinates would look like the point 2, 3, like that. But if you need to change something to polar coordinates show that same 2, 3 point, but they do it by instead if we have that same point right here, they don't focus on the x and y values. They focus on how long the line is from the origin, which is called your magnitude, and then the angle to get to that. And so polar coordinates need to be changed around, usually using trigonometry. We would find a triangle there and say if this side is 2 and this side is 3, I could find the magnitude using the Pythagorean theorem. So 2 squared plus 3 squared. If I take the square root of it, I will find this magnitude. I'm just going to call that C. So 2 squared is 4, 3 squared is 9. So in this example I just drummed up, this happens to be the square root of 13. And then you would find the angle by using some sort of trigonometry here to say this angle is found with the tangent, saying the tangent of this angle here will be the opposite side, which is 3, over the adjacent side, which is 2. So we could find that angle the same way. I'm going to type it into my calculator right quick here. And I'm keeping this in degrees for now. So it's about 56.3 degrees in this example. So again, what I'm doing over here to the side is not working on the problem you see on the left. I'm just kind of reviewing, talking about rectangular coordinates and polar coordinates. So if we find the angle right here is 56.3 degrees, we can write the polar coordinates as the magnitude, which was 13, square root of 13, and then the angle was 56.3 degrees. So all I'm showing is when you label this point in rectangular coordinates, you label it 2, 3. When you label the same point in polar coordinates, you label it as the magnitude and the angle. And so the conversions between the two are what they're using in these problems here. So they're saying here, in a complex number, and by a complex number, we're going to get back to this form. They're saying the z has a magnitude of 6 and an angle of 70. So if I just graph that, the first thing I'm going to look at is the angle. I know since it's under 90 degrees, it's going to be in this first quadrant here. And so I'm just going to estimate. It doesn't have to be perfect. I'm going to say that's about 70 degrees. It should probably be up a little higher, but it doesn't matter. This is just to kind of sketch out to solve. So there's my 70-degree angle. And then we're just going to say the line I just drew is 6 units long. And I'm going to make a triangle out of it. So those are the given pieces of information. And if they want us to write it in this form, this is how we need to solve it. We need to basically find the x and y values. Because if this plane, this isn't just a regular xy axis, this is the real number part of the complex number, or the a, and then this is the imaginary, or the b component. So we're going to use a to represent this side of our triangle and b to represent this side, because those are the units we're going to eventually turn things into on our final answer. So to solve this, I'm going to rewrite my triangle because we know it's in the first quadrant, so I'm just going to keep it by itself here. And we knew this was 6, and we know this angle is 70. So we're just trying to find side A and side B. So to do that, we're going to need to use trigonometry. So I'm going to say, if I'm looking for A to begin with, let's say, I am going to start with my reference angle, which is 70. And I need to decide, am I going to use the sine, the cosine, or the tangent to find this? Well, I'm going to scroll up a minute so we can remind ourselves of sine, cosine, tangent. Cosine is the adjacent side over the hypotenuse. So if this is my reference angle, the A is the adjacent side, and my hypotenuse is this line, the line across from my right angle, and the hypotenuse is 6, so that's the thing I already knew. So I just chose to use my cosine. So cosine of 70 is the adjacent side over the hypotenuse. So to solve this, I'm just going to multiply 6 on each side of the equation to get rid of it on this right side. So these cross out. I'm going to put the A on this side. So it's going to be A times 6 cosine of 70 degrees. So simply you put this in your calculator, and I'm going to do it right now so I'll make sure I know how it works out. So I'm going to type in 70, and then I'm going to hit the cosine button, and that gave me a decimal of 0.342, and I am going to now multiply that by 6 before I write that down. And again, they're asking me to round to the nearest thousandth, so I'm going to write 3 decimal places. So I just found out A equals that. So now I need to still solve for B. And because B is the opposite side of my reference angle, and I know the hypotenuse, I can solve for B using sine. So I'm going to say the sine of 70-degree angle is my opposite side B over my hypotenuse, which is 6. I'm going to multiply by 6 on both sides. So B will equal 6 times the sine of 70. So I'm going to plug this into my calculator, making sure I'm in degree mode still because I'm using degrees. So I type in 70, I hit the sine button, and then I'm going to multiply that by 6. So my calculator says 5.638. So I just found my A and my B, and in the problem, they want it in this form. So my Z equals A, which is 2.052, plus my B, which we found was 5.638, and then you need to have the I on there because that's what puts it in the standard form, because we're dealing with the real and imaginary axes. So you type those figures right in there. They already typed the I for you, so you don't type that. And that's the answer to that type of problem. So I know these are pretty complex. Let me know if this is stuff you haven't been doing before, because this is quite a leap Khan's taken in this concept track.